Alright, this week I'm going to cover combinatorial testing. Now this is mainly a test technique in order to simplify all the test cases that you are coming up with. We've talked a little bit about code coverage, or lines of code coverage, or branch coverage. And here we want to come up with other ways that we might be able to, at the system testing level, simplify the whole testing framework. If you were to actually sit down and try and evaluate every single path that's possible through your program, you can quickly see that that is not pragmatic. But even at a systems level, there are other ways that we can simplify our testing. And so what combinatorial testing does is basically coming up with a way how we can combine tests together in order to simplify the number of tests that we are doing. And most of this is intuitive. Once you check for passing null to something, that's probably the only test you need to. You don't need to check if it's null and then something else, because if the first thing is null, you're going to ignore it as well. Then another example might be if you have a greatest common divisor and you pass in 1 as one of them, you don't need to even do any more work because it's always going to be 1 that will be the answer. Alright, so we're going to cover category partitioning, pairwise combination testing, and then catalog-based testing. So the basic idea is that there's distinct attributes about our testing framework. For example, our browser may be different types in our operating system. We want to systematically generate the combinations to be tested. We want to be varied and be able to capture enough of these possible corner cases to give us reasonable confidence that our program is working sufficiently. The three ideas that we come up, or the book presents, is a category partition testing. And this is what I would say is most of the intuitive way that we would go about it. We would manually inspect for different values and try and come up with the correct test cases. There's pairwise testing, which is a little more systematic way of approaching it and trying to come up with a simple combination of relatively small number of test cases to evaluate your software. And then lastly is catalog-based testing, and we'll get to that later. So category partition, this is what most people think about, or what I think is intuitive for most people. You decompose the specification. You have this idea of what your program should be doing, and for each feature or function or input, you think of the parameters that can go in. Maybe you have a website, you can put in a person's name, or you can put in a bad name or some other type of name. Maybe you have an age group as well, or some environment variables that go in. So what you want to do is, once you have these parameters, you want to identify what's actual relevant values, normal values, aka username, a normal username, boundary values, maybe username that's pushing to the limit or the minimum number of values, special values in case there's a special username. Good example of this would be administrator. And then anything that might produce an error. Not enough characters, too many characters, illegal characters, or someone's trying to do an SQL injection. And then lastly, you want to try and introduce some constraints to try and simplify the number of test cases you may have. And I do think an example really helps out, although the example they give comes up with is a little overly formal, so I'll try and simplify it for you. So you can start with an informal specification, which is what most of us are going to do. For example, you may want to check the validity of a computer configuration. Let's say you're trying to build a computer and you want to see if it's a valid configuration. So you might have a model and set of components. So in their example that they're coming up with, models are not characterized by logical slots for components, which may or may, et cetera, et cetera. What they're trying to say here is required slots of this example: laptop, computer, including a screen, a processor, hard disk, memory, and OS. Of these, only the disk and the memory are implemented using actual hardware slots on a bus. The optional slots include either a device like a CD or DVD writer or something else that you can connect to it. And then they go into another example of what a slot may be. Default configuration is 20 gigabytes, although you can choose 30 or 40. Since the hard disk is required, a slot empty is not allowed choice for the hard disk. And the default OS, they just came up with Rodin OS 3.2 Personal Edition, but there might be a mobile server edition as well. And the mobile requires 30 gigs. So once you have an idea, in this past example, we're coming up with a way to test a computer configuration. There is no hard and fast way for choosing categories, so unfortunately this is not a trivial task. You actually have to sit down and figure it out. Categories are actually going to represent the designer's judgment, so you need to actually be good or well versed on deciding how to pick your test cases. So they usually require experience and knowledge, which unfortunately you only gain by trying it out. So first thing that you want to do is identify the independently testable units. So for example, in your model, you might have a number, the number of required slots for the model, and then maybe the number of optional slots. And then for the different components, you can think of which components can be with which model. The number of required components with selection cannot be empty. Right. If it's required, you need to be able to fill them all up. You need to actually then select your components. And the number of optionals with selection cannot be empty, if you actually are getting some optional ones. And then you need to select your optional component. And then there's a database, of course, number of models in the database and components as well. Then you need to come up with what are identifying actual values. So how many model numbers can there be? How many slots can there be required? How many optional slots can there be? Etc., etc. You may come up with a boundary value testing, extreme values, then values outside but are close or just outside the boundaries. One too many slots in this computer, or one not enough. And then of course erroneous values. I have 3 required slots and 42 components in those slots. It doesn't make sense. So listing it out, model number. What can be a problem? Well, it can either be malformed, not in the database, or a valid number. Number of required slots, we'll say it's 0, 1, or many. Number of optional slots, 0, 1, or many. And then they go on. Selection of the model, you might have omitted slots, which is fine. Extra slots, match slots might be a problem. And the complete correspondence, if actually things match 1-to-1. The number of required components with non-empty selection, maybe 0. Less than the number of required slots, or then if it's equal to the number of required slots, then you're actually filling up all of these slots with components. What could happen with required selection? There might be some defaults that you do start with. Everything's valid, greater than or equal to 1 incompatible, greater than or equal to 1 with incompatible with another selection that you made. For example, maybe you have a component that you want to put inside your optional slot, but you have no optional slots. Might be incompatible with the model, that would have to be in there, or maybe it's not in the database. Number of optional components with non-empty slots, again, 0, less than or equal, and same thing with the optional. And whatever, databases. So models in database, 0, 1, or many, and components as well. Usually 0, 1 are special values because they sometimes do not cause anticipated behavior, especially 0. Always make sure you test for nothing. All right. Next, you want to do constraints. Hopefully you can see that in the previous list there was a lot of different choices you could choose from. In this example, they have over 314,000. This is a foreign book, so a dot right here actually means comma to us Americans. 314,000. Most of which are impossible. For example, you have 0 slots and you test with at least 1 incompatible slot. Well, that doesn't even make sense because you don't have any slots, so how could one be incompatible? So you introduce some constraints to rule out impossible combinations, and this will reduce the size of your test suite if it's too large. Intuitively, you think about doing this. You're not going to ever write a test case for 0 slots and at least 1 incompatible slot, but the book is trying to come up with a formal way to introduce and explain these things. So the first thing they're going to talk about is the error constraints. This just tells you if there's an error, and if something ever comes up with an error, you're done. You don't need to test anymore. The most important thing is no need to test a possible combination of errors because you only really need to test once that the error does pop up correctly. This, of course, assumes that handling an error can bypass other program logic, which is not always the case, but hopefully is an assumption that you can make with your program. So if the model number is malformed, that's an error, you're done. What this means is, once it's a malformed model number, you don't need to test for a number of omitted slots or complete correspondence or number of slots, et cetera, et cetera. You don't need a test for anything else. You just need one test for malformed model number, done. Same thing with non-database, omit slots, extra slots, mismatched slots, a number of required slots with non-empty selection, et cetera, et cetera. Put this all out from 314,000, you go down to 2,700, which is really good. But really, we're just getting rid of all the ones that are obviously incorrect from our calculations. Normally, most people would just start writing test cases. They're not going to test for these, but it is good to formally see how much just putting in an error constraint simplifies the problem. The next one can be a little complicated to understand, so I'm going to see if I can explain this to you. So they have a property, if property, to rule out invalid combinations. All they're doing is trying to rule out invalid combinations. A property is going to group values of a single parameter to identify substance. So if something has this, a property is just identifying a property, aka it has this. Then an if property is going to say if you have this property that I was talking about beforehand, then you do something else. So property is just identifying it, and then if property is when you're actually testing if that property exists. For example, over here, number of required slots, 1 and many. You have the property required slots not empty. So that's just saying if you have 1 or many, then the required slots not empty property we'll just say is true. Why is that important? Well, if you're down here to number required with non-empty selections, if your number that you have is less than the required slots and you have the required slots is not empty, then it's an error. If required slot's not empty and you're at 0, then it's also an error. You don't have to test anything out. The point here is you just need to test that this property is true and then an error test for one of these. You don't need to test for anything else. That's the point of this error. It's just you're going to make a separate test for this pair, and then you don't need to test all the combinations afterwards. Because notice you could have the combinations here, and then you can have any number of combinations with the optional components, as well as model number, et cetera, et cetera. So that eliminates a lot of these test cases by coming up with a property to eliminate basically duplicate test cases. And that goes from 2,700 to 908. So looking good, doing great. Last thing is a single constraint, and this is just indicates a value that testers actually choose to test only once to reduce number of test cases. This is not necessarily something that is not an error, because an error is saying that you're done and you error out, you're testing that there was an error. Single is just saying you need to just test that this is valid once. Here's a good question. Number of required slots is 0. Well, if you don't have any slots, you just need to test that once. You don't need to test different model numbers or whatnot. You just need to test if it's once. Properties not equal and single. All right, so they're saying actually, and then that's another only single. You have to test once. In other words, if you only have one slot, you only need to test that for one. It's when you have many that you're going to have to test for many different combinations. Same thing for optional, et cetera, et cetera. And if you actually multiply this all out, you go from 908 to 69 test cases, which is very manageable in a regression test suite. Keep in mind that 908 is actually pretty manageable, but if you have a very large program, that number would be much higher and would not be acceptable. And here's their long list of how they put everything out in a formal specification. This is actually not a bad way to go about it. Notice that the errors only have to be tested once, and then singles only need to be tested once as well. And then the two properties that are combined, you only need to test the combination of the properties once, is the point. All right, so the category partition gave us a nice systematic approach to identifying the characteristics of values and then coming up with the different combinations. But it can grow very rapidly, and can we use a non-exhaustive approach? Hopefully you can see from the previous one that would be very, very time-consuming, especially if you have a large program, although maybe you have the money in order to do it. Another way to go about it is something called pairwise combinatorial testing, and this is going to give us a kind of a more systematic approach that's not exhaustive. The idea is you're going to come up with that you have pairwise combinations. In other words, when you've tested two combinations, that test makes sure that those combinations work. So if you pass a test with two combinations together, you're good to go. And the idea behind this is that Most failures are triggered by either a single value or very few combination of values. So hopefully you can have one test case that might cover multiple different pairs, in which case one test case suffices for many. I think an example really drives this home. For example, we want to test a different control display. Well, it might be able to do full graphics test in limited bandwidth, its mode, have different languages, have different fonts, have different colors, have different screen size. Well, how many different combinations are there? Well, 3 times 4 times 3 times 4 times 3, 432. Naturally, in a large system, there'd be far more than this, but we're just using this as a simple test case to show you how we can get 432 down to a far smaller number. Well, if you come up with a pairwise combination, it comes out to about 17 tests. You'd have to sit down and map this out, but what's going on is knows that English and monochrome together is being tested, full graphics and minimal is being tested, full graphics and monochrome is being tested, full graphics and English is being tested, and handheld is being tested with all these others. So we're saying that you don't need to do any of those pairwise tests later on. So notice you just have a couple more under English, and then French you have the same thing. And what's going down is you'll notice these dashes means that you can put whatever you want in there. It doesn't really matter. But every pair has been tested together in at least one test. And that's what brings it down to 17 test cases. You can add a couple more constraints and make this even simple. For example, color monochrome not compatible with screen, laptop, and full size. So maybe your map goes from this list, or screen size is just handheld, and then laptop and full size can have these combinations. And that'll actually simplify things significantly. All right, so I talked about category partitioning, which was a very formal way to go about it, and pairwise or in-way testing, which actually gives a systematic way to come up with test cases that hopefully are still going to cover the majority of what we need. Now we still need to come up with a manual step to make this more systematic, so I'm going to pause here before we go into the next section.